Next set of problems is really figuring out how many ways can I write these points, and it turns out there are an infinite amount of ways you could do that. We're just going to focus on parts A and B. So directions, plot each point in polar coordinates and find two other points. And we want to really pay attention to part A and part B only. So let's look at part A and B. Not that C is too hard, just with the time that I have, I really want to finish this under 10 minutes or 12 minutes. So I'll make another video. So if I take problem number 34, for example, a couple of problems just to see this. And if I go to so on this case, if I take that point, I'm going to rotate the 3 pi over 4. This is 3 pi over 4. I'm pointing in that direction since r is positive. 1, 2, 3. I'm right here. That's number 34. Now, I want to approach this same point. I could approach an infinite amount of points. The second round, I want to approach that. I want r to be positive, so I want 4 still, but I want to rotate in negative rotation. So how do you think I can approach that? Well, wouldn't you say if I rotate in negative rotation, take 3 pi over 4 and subtract 2 pi, wouldn't that be all over 4? That's 8. 5 minus 8 is negative 5 pi over 4. So here, I rotated in negative rotation. I'm still pointing in the same direction, and there I am, the same location. I can do this not one or two different ways. I could do this an infinite amount of ways. And if I proceed and look at this case, they want r to be negative in this case. They want me to have a negative 4 for r and theta to be positive. If theta is positive, if I'm rotating in positive rotation, and I want to be somewhere in quadrant 2, if r is negative, shouldn't I be pointing in the opposite direction of quadrant 2? And since r is negative, I move in opposite direction. So, if this is 3 pi over 4, shouldn't I be pointing at this point, which is 7 pi over 4? If I rotate to 7 pi over 4, and r being negative, I will push in the opposite direction 4 units, and I am where I would like to be. I want to do one more like that. Keep in mind there are an infinite amount of solutions, and they all work. We just want to pick a couple of those. And let me see if I could see. Let's go for 40. Same directions. If I would go ahead, and if I shrink that. So first I need to plot this point. I want to figure out where that is. Rotate to negative. This is negative pi over 3. This is negative 2 pi over 3. I'm pointing in this direction. Since r is negative, I'm right here. Part A. They want r to be positive and the angle to be negative. If they want r to be positive, shouldn't I be pointing in the same direction as this angle? So, if I'm going to rotate, shouldn't that be a rotation all the way around? And what would that be? Because in part A, they would like for the angle r to be positive and the rotation to be negative. So, if I'm going to rotate to the reference of... Oh, did I mess this up? No. What would this angle be? Isn't that negative 5 pi over 3? And if they want r to be negative, shouldn't I be pointing in the same direction as the original? right? But they want the rotation to be positive. So if I'm going to rotate in positive rotation and I want to be at this location, well, let's see. If r is negative, I should be pointing in the opposite direction. This way, when r is negative, I move in the opposite direction. And what would be pi over 3 in the third quadrant? That would be 4 pi over 3. Last aspect of this section is for us to look at converting from x and y to r and theta, and actually the last two sections. One part states, well, x and y are rectangular coordinates. Convert the equation to polar coordinates. And here we go. So if I take the first problem, problem number 70, doesn't want to move. Now, isn't this r squared? Isn't this r the cosine of theta? So do we know how y equal f of x? Guess what? In polar land, r equal f of theta, meaning we should solve for r if we can. R squared minus r the cosine of theta equals 0. Factor an r out. So either r equals 0 or r equal the cosine of theta. And there it is. If you can get r on one side, everything else on the other side, you're done. If I would go ahead and look at another problem, something like number 72. So converting, there are four formulas. Let me remind you of what that is really quick. If you remember correctly, that was right there. R squared equal x squared plus y squared, tan of theta equal y over x, and x equal r the cosine of theta, and y equal r the sin of theta. So going back and forth. When they say get rid of x and y, I only want to see r and theta. So if I was to go ahead and say, well, what's y? That's r the sine of theta squared. And what's x? R the cosine of theta. Now, r squared sine squared of theta equals twice r the cosine of theta. Get everything on one side, 0 on the other side. Factor an r out. So either you would say r equals 0, which is a point, or r sine squared of theta minus twice cosine of theta equals 0, or sine squared of theta equals twice the cosine of theta, and r would be twice the cosine of theta divided by the sine squared of theta. And as long as you get me r on one side, everything else on the other side will fine. You don't need to simplify it any further. That's not simplifying. Just write it different. And if I go by the last okay, what's happening? And if I look at the last problem, somehow it froze. Okay, somehow